This video is going to cover the End Area Volume tools for Open Roads Designer. Okay, so right now I'm in my corridors file for Route 54. You can see the corridor back here in the background. You got the template drop, so the 3D view is showing in my 2D view. The important thing about when we go calculate our earthwork is that we want to make sure that our feature definition, or what was previously known in SS4 as our design stage, is set to final. So right now they don't have the colors working. In SS4 the corridor would be red, but you can see it's green and it doesn't change colors yet. It's a bug, they're working on it. So if I click on that one of these handles here and I go out to the properties, I can see that my feature definition is set to 1. Now again, feature definition is what SS4's design stage was. So this is saying take our template drops and multiply it by 1. So in the background I have 25-foot template drops. I can show you that by clicking on here and going to the corridor objects tool, and you can see my first template, or my only template through here, is 25 foot. So at 25 foot times 1, I'm getting a template drop every 25 feet. Okay, I'm going to get extra as well, as it likes to do cardinal points, which is a PC, PT, or any vertical points that we have out there. It'll drop a cross section. Okay, so this is our corridor. It looks good to go. You can see I also have a ramp 4 in here, and it's tied in nicely. If I come over to the 3D window and I rotate it around, you can see it's all tied in real nice. We're talking together really nice, working together good. And we're going to do some end area volume for just Route 54. Now the tool, the way it works right now is you have to create a new file and only bring in the corridors that you want to see if you're calculating just for the one. Now if you're calculating for, you want to see calculations on all of it, both corridors, or how many corridors you have, then you bring them all in. But for this exercise I'm going to show you how to do the Route 54 through a section right in here. I want to do some cut and fill, and most of this project is cut, but right around here in ramp 4 we've got some fill, so I want to incorporate that in this video. Okay, so that covers the corridor part of it. Let's go into and create a brand new file for our earthwork, our end area volume. So when we do this, we're going to do a 2D file. I'm going to use that, and I'm just going to call this one XS underscore earthwork underscore, and I'll give it a video, I'll call it. So XS underscore earthwork underscore video. And I'll hit OK. And we'll take a moment for this to go out and create us a brand new file that's blank. Now, the way the process works is we're going to create some name boundaries out there, and then we're going to create a couple of meshes, one for the cut and one for the fill. And then we'll calculate from that, and then we'll go back and label our sheets with the values of the end area volume, or the earthwork. Okay, so here's our blank file. First thing I like to do is we want to open up our reality modeling workflow, and then we'll go out and attach a coordinate system so it matches all the other files. And again, we've done this in other videos. We want to do from file, and we'll pick one from our folder that we're working in, and we're going to look for that corridors Route 54. Bring that in, and I'm going to use this default one. So it's applied the NAD 83 Missouri State Plane Coordinate System to our file. We can go ahead and close out of this, and then we'll go back into the Open Roads Modeling workflow. I'll go to the Home tab, and we're going to attach the files that we need to create our end area volumes. So use the attach tools, reference dialog, do a tools, attach, and files that we need for this, we don't need all the stuff. All we need is our proposed geometry, which would be this corridors, our civil geometry, which is our alignment, and then we'll find that terrain, and we want our terrain. So those three is what we're going to bring in. So I'll hit add, and then OK. They say it doesn't belong to the active set, but it will. So we'll hit OK. Now here's the important part. When we're doing end area volumes, we do not want to use the nested depth. If we use nested depth, it's going to bring in that route or that ramp 4. And we don't want that ramp 4. We're calculating just for Route 54. So we'll leave it at 0 and make sure it's at 0. And then we'll hit OK on all three of these files we bring in. And this is similar to SS4, the way we would do it there. Okay, I'll hit the fit view and close out of my reference. I will hit the F4 key, select the terrain, and make it active. Got to have that terrain active for cross sections. Okay, and the next thing I want to do, I'm going to zoom into where the Route 54 and Ramp 4 are at. And you could see I have corridor here for Route 54. But I don't see anything on Ramp 4 because that's all we brought in was that Route 54. So I'm going to hit F6, and you need to do this if you're going to be doing any of the creating sheets. So you can see out here we're going to do this area right in here where there will be a little cut and a little bit of, well, a lot of cut and a little bit of fill in here. That's the area we're going to look to do this at. Okay. Next step in this is to go ahead and open up our drawing production tab, and then we're going to create a name boundary for this area. So we'll go to the name boundary tool, and we're looking for the cross section, the civil cross section tool, which is the 4th icon on the toolbar. We'll pick that, and we want a 10 scale sheet, so we'll pick 10. Our detail scale will be 10. We're good to go on that. The next thing we need to do is identify a path element, as it says in our status bar. So I'm going to pick the 54. And for this project, or for this exercise, a demo of this tool, I'm going to start at 617. Now again, we have a station equation out here, so we will be working in region 2. Anything before the station equation is region 1. Anything after is region 2. So I'm going to come out, I'm going to go to my start location in the dialog, and I'm going to go to 617, plus 00, give it a space, and R2 for region 2. Go out and accept that, and you can see it's rubber banding from my cursor. And then our stop station that we're going to use is 622 plus 00 space region 2. And lock that in as well. So this is the area we're going to cover, right in this area here. If your shapes need to be moved, there is another video that is out there that goes through moving these shapes after they've been placed. Right now I like my left and right offset at 140. I could bump it a little bit to the left, or to the right, maybe 130 and 150. Could do that. I can move these wherever I want. But I think it's pretty good where it's at. So I'm going to accept that stop station. And the next thing it wants to do is go ahead and bring me to the create drawing. I'll hit OK on this. The thing about this is we want to do our annotation group. So let's do that first. Annotation group. And I'm going to do excess annotation without grid. So we just drill down into our folders till we see this. It's the only options in there. And then you have an option to open the last model or not. I'm not going to open it. I'm going to just hit OK. And on this one I did 50-foot intervals for the cross sections. And more than likely you could use 100 or 50, whatever you need to do on your project. I'm going to just stick with 50 on this one. And you'll see at the bottom right, it's processing. We're at 40%. And so this is just creating our name boundary so that we can go out and create our cross sections for our earthwork. So here they are. You see I don't need to move them or anything. They look like they're pretty good shape. Again, when you see that the shape's not transparent, you just want to get in that window too, and then change your transparency from the View Attributes toolbar or button. Put transparency, and now we can see through them a little better. And when you rotate it around, it looks nice. You can see it. Okay, so our cross-section shapes are out here, and this again represents each one of the cross-sections that we're going to have, cross-section models. We have our shapes in 2D, and we have our shapes in 3D. Okay. So now we have that. The next step is to go ahead and create our meshes for our cut and our fill. To do that, you got to go to the Home tab in Open Roads Modeling, Home tab, and then you're going to go to the Civil Analysis tool. And in here we have a Create Cut and Fill Volumes tool that will create a mesh, one for cut, which will be blue, and one for fill, which will be red. And then it's going to calculate using those shapes. That's your proposed shape, or your proposed geometry that you have out there. It creates it for the proposed, and we'll compare it to the existing mesh, existing terrain, and give us our volumes. So let's do this, Create Cut Fill. It's going to ask us in this dialog and on the heads-up display what feature definition we want to use. Now we have it defaulted to volumes cut and volumes fill for cut and fill. And we'll talk in later videos about the compute unsuitable, custom, and substrata. So I'm going to go ahead and accept through this by left-clicking on a blank area. And I'll hit no on these. And it's going to start processing. That's that data point to accept it. Process bar. That's going out. And it's going to do it for the whole project, all the way through. So if we had ramp 4 in here, it would calculate that as well. You would see all of ramp 4 being calculated. But in this exercise, we just want to calculate the earthwork involved with our Route 54. Okay, so you see, now here's our blue shape out there representing our cut. Now you can get some information off of that just by selecting it. And if you get the heads-up display, you can get this properties. And in the properties, it's going to tell us the feature name, which is features cut. But it also gives us our top sloped area, planar area, and a volume right here. Same with the fill. You select it, and if you get it selected, which I do, I'll go to properties this time, and you can see over in the properties tab we got all the information, and you also get your civil quantities as well. Okay, again, now if you do the mesh, it's going to go throughout the whole project. Okay, so it's not giving you for the area that we're wanting to see. We want to see just between these station ranges of 617 to 622. Okay, now if I go out and I look at one of these cross-section models, and I'll just go to a drawing model of maybe we'll do 618. If I look in here, you'll see it's giving me my cross-section at 618. It's giving my elevation and offset and all my slopes because we set that annotation up. And you'll also see there's a shape that's kind of created through here. And it's got a cyan color to it that represents our earthwork. Okay, and then you got, and the cyan colors, the cut, the blue cut, and then the red is the fill. Okay, and we're working on this error here where it's labeling where it got clipped. Bentley's working on that. But getting back to the thing, the process that we want to do is we want to see some calculations in here, and there's no calculations for our earthwork whatsoever. We do have shapes, but we don't have any calculations. So I'm going to go back to my multi-model view, and in here I'm going to want to calculate where my sections are. If I select one of these shapes and I look at it, I'll go to the properties once it's selected and open up my name boundaries, and I look at this. Down here at any of these sections, there's an end area volume XML fragment that's missing. Okay, so there's nothing here. We need to apply that fragment to this shape for us to get quantities. So I'm going to go out and select in a blank area, go back to my window 2, and I'm going to go back to Home, Civil Analysis Tools, and there's an option down here to do End Area Volume Report. Okay, so it's going to calculate our End Area Volume Report on whatever we want to see. So I'm going to select it. Right now it says name boundary group of Route 54. If I didn't want that, I could hit the down arrow to none and it will calculate everything. But I want 54. So I'm going to go to Route 54. And this is looking for that name boundary group, which is all these shapes that are out there. And it's going to calculate only within that area. So with that selected, I'll go ahead and left click to accept it. And it says to select start cross section, name boundary for volume exception. So if we had an area in here that we didn't want to calculate, maybe we had a bridge coming through here and we didn't want it, we could left click on shapes, these cross section shapes, and remove them from our calculations. Okay, so you just simply left click on them and it removes it. For this, we want to use them all, so the other option is to reset to complete. So we'll right click to reset. It's going to process and it'll bring up a report. We went through reports in other videos. First thing I like to do is check my settings on them, my format options, and make sure I've got convert to cubic yards checked on. That's important. Plus my stations. I want to make sure they're English stationing, not metric. And then maybe my degrees, minutes, and seconds on my direction and my angular. Once I get that set up, it's all good. We'll hit close. Now, talked about it in other videos that if you did have to change these and you do click it on and off, you'll notice nothing changes in the background, whereas it was dynamic in SS4. When you clicked it, it happened. In Open Roads Designer, you have to close the box for it to process, and then it shows what we want. And again, there's all kinds of different reports out here. We've got a volumes one here at the bottom. It goes station range. It shows us our cut and fill area. You see the cut, fill for each station. So this is going from station to station all the way down, giving us our information. I'm going to leave it at End Area Volume, and I'm just going to move this dialog out of the way, this whole sheet, and come over to my 3D window, and I want to select one of those shapes again and show you what happens. Okay, so it's selected. I go back to Properties. If I open up this name boundary and select one, down here at this End Area Volume XML fragment, you can see it's applied it to the shape. So now we have that XML, we're good to go, and we should be able to label our cross sections. Okay, and that's the next part of it. So what we need to do is get into a drawing model. So I'm going to go to we'll pick 617 this time, open it up, and you can see all the information out here. We want to apply our new quantities to it. So to do that, what we want to do is go from Home, the Drawing Production again, and we want to do a model annotation. And we're going to annotate our model. Now, if you wanted to, you could change, like I used without grid right now. You could remove everything and put whatever you want out there. All we're wanting to do, is I like the way it looks right now, I'm just going to add the End Area Volume stuff to it. So it wants to know if I want to do it to all the models, and I do. So I'm going to hit the arrow key to go to yes, or you just toggle this on and off. And then I'll accept it. Now it wants to know what I want to annotate it with. I'm going to change my group. I've already annotated it with that without grid. So the next thing I want to do is add the information of the End Area Volume. So I'll open up my cross section, my drawing, and go Excess EAV Annotation. And then all I have to do is accept it, and it's going to process each one of those stations. And you'll see up in the upper right hand corner, we've got that information. Now let's go to one where we've got a little bit of fill to it. I think 618, 619 had some fill. Yeah, so we can come in here and we can say we're at 619. It's populated this earthwork box. So we're at 619. Our area for cut is 613, and it will round up. Our cut volume is 1128.9. And then we also have our fill out there for 619. So I like to highlight this so I can see it. And you also see 429, 429.5, 847. So it matches the report, and that's what we want. We want that to be accurate. So I'm going to close the report out, and I'm going to go to a sheet file so we can see how the sheets were labeled. Go to 620. So we get our 620 and our 620 plus 50. You can see that it's been annotated in the sheets as well. So that is basically how we go ahead and do it, how we calculate end area volumes in Open Roads Designer.